Hello everyone, welcome to Chemoholics, your one-stop channel to make chemistry simple, easy and exam ready. So in the series of solving analytical chemistry numerical for Geochemist examination, I came up with a new numerical question that came in 2017 paper, and this question is of 10 marks. So the question is as follow: a mineral corresponding to orthorhombic system. Okay, so the system is given here is orthorhombic system. So as for orthorhombic system, A is not equals to B, is not equals to C, but alpha equals to beta equals to gamma equals to 90 degree. Okay, so this is the orthorhombic system. Right, was studied by powder XRD using X-ray wavelength. Okay, I think it is going to be question from Bragg's equation. So lambda here, lambda is equals to 1.54 angstrom. The X-ray diffraction planes are 100, 010 and 001 were observed at 2 theta of 22.5 degree, 9.8 degree and 28.4 degree respectively. Find out the dimensions of the unit cell. Okay, find out the dimension. So first question is dimension, right? Dimension means they are asking about the length of A, B and C. Let's say this is A, this is B, this is X, Y and Z. Sorry, this is X, let's say this is Y and this is Z. Okay, so they are asking about what? A, B, B and C. So they are asking about these three dimensions in the question. And what they have given the planes. Okay, 100 plane. So 100 plane means it is cutting X but not so this is 100 plane. Okay, 100 which is cutting at A. And as for second plane is what? 010. Okay, 010. So basically this is 010 plane, and they are also asking for 001. Okay, 001, so it is cutting Y at 1. So these three planes are there. So this is 010 and this plane is 001, and they are asking the dimension. Let's see from the Bragg's law. Bragg's law. According to Bragg's law, we know that n lambda is equals to 2d sine theta, right? If we have planes of this HKL planes, by using this value formula we can calculate the anything which is not given in the question. So here, because n is not given here, so when n is not given we will assume it as 1. Lambda is also already given in the question, and this theta is already given in the question as 2 theta. So n is 1 and this theta is going to be 2 theta divided by 2. Okay, and lambda is also given in the question. So now by utilizing this formula we can calculate the dimension. Okay, so if we are going to take this 100 plane, what we will be able to calculate? We were able to calculate the distance between 0 to A. So this distance we are able to calculate by using this plane, and this distance we can able to calculate by using 010 plane, and this distance can be calculated by using this 001 plane. Okay, so let's solve this problem. D100 is equals to lambda divided by lambda divided by 2 sine theta. 2 sine theta. Lambda is 1.54 angstrom divided by 2, and sine theta. Now sine theta, here it is theta, so if we divide it by 22 divided by 22.5 divided by this, so it is going to give you 11.25, and if you solve it, 1.54 to multiply by, and the value for this 11 point is 0.195, and when you solve it, you will find out the value of 3.95 angstrom. 3.95 angstrom. Okay, so this value is nothing, it is the distance from this origin to A. So from this plane we were able to calculate A, from this we were able to calculate B, and from this we were able to calculate C, and that's what they are asking in the question. So this is A. Similarly, by using 0, 1, 0 plane, 1.54 divided by 2 multiply by sine, and 9.8 means 4.9 is equals to 1.54 angstrom divided by 2 multiply, and the value for this is 0.0855. 0.0855. Okay, this is the value of sine theta. Then if you solve it, you will find it out 9.01 angstrom. Okay, then similarly we can calculate 001, 1.54 multiply by 2 sine, and 28.8, so it's going to be 14.4. 1.54 angstrom divided by 2 multiply by, and the value of sine 14.4 is 0.249. 0.249, and when you solve it, you will find this answer as 3.09 angstrom. Okay, so with this we have already, first question was, this part was find the molecular dimension of unit cell. We have able to calculate this value, right? Now, and the number of the molecules of the mineral. Okay, they are asking the number of molecule, means Z. Do you remember there is a formula, and they have given a molecular weight and density. So we have studied this formula for density is equals to Z, number of molecules multiplied by molecular mass, which is already given in the question. Okay, then divided by Avogadro number and volume. So this is the formula where we already have this density, we have molecular mass, and this is they are asking for this, and this is Avogadro number. So this is already a constant. Now first off, to solve this problem, to find out the value of Z, we need to calculate the value of this V. So V is nothing, it's a volume of unit cell. So first of all, we are going to calculate this value, and because here the angle is 90 degree, so simple we can say it's a cuboidal system, and for cuboidal system, volume is nothing but the multiplication of their dimensions. So A multiplied by B multiplied by C, and we already have this value as 3.95 angstrom multiplied by 9.01 angstrom multiplied by 3.09 angstrom, right? This is already we have, and if you solve it, the value is going to be 109.91 angstrom cube. But here if you have to see that density is given in centimeter, so first of all we need to make it convert this angstrom into centimeter, and we already know that 1 angstrom is equals to 10 to the power minus 8 centimeter. So when you put this value here, you will find your answer would be like 109.91 multiply by 10 to the power minus 8, and it has a power of 3, multiply by 3, and you can convert it into centimeter, so centimeter cube. So 109.91 multiply by 10 to the power minus 24 centimeter cube. So this is the value of your volume. Now we can easily calculate the value of this Z by putting all the value in the formula. Okay, so let me put this value here. Okay, now let's calculate Z. So D is equals to what? Z multiply by M, Avogadro number, and volume. So Z is going to be density multiply by volume multiply by Avogadro number divided by M, and density they have already given at as 4.2 gram per centimeter, multiply by volume we have calculated 109.91 into 10 to the power minus 24 multiply by 6.023 into 10 to the power 2 into 10 to the power 23, and mass molecular weight is also given over here 140. And if you solve this problem, it is going to give you a value of 1.99, or we can say it is also going to be equal to 2. Okay, so here they have used two formulas. Combining two formula, they have given you basically two questions. First we need to use this Bragg's law to find out the dimension for each of the plane, and by drawing you can see that if it is 100, it is on x-axis, and x-axis we have the value of a. So by utilizing this plane and the theta for this plane, you can able to calculate the first dimension. Similarly, you can also find out the value of this y and the value of z. So this is the part of first question, and by utilizing this density, molecular weight and volume, you can also able to calculate the number of molecules, or they can also ask you some other thing as well. They can also give you the Z, and they can also ask you the molecular weight of the unit cell. Okay, so this is how you need to solve this powder XRD problem. I hope you are able to understand it, and if you like it and if you enjoy this video, please do not forget to like, comment, share and subscribe. Thanks for watching.